Welcome back to our lesson practice review, where today we go through chapter 3, lesson 7. We're really focused on sketching our polynomial graphs. We've learned a lot of things throughout the last couple lessons, including what the degree does for our end behavior, what our x-intercepts might be, what multiplicity is, so we can see kind of what is actually happening at each of those x-intercepts, and then being able to connect all those pieces to kind of give us a good sketch of what the polynomial looks like. Now, these are definitely sketches and only looking at the main facets like the intercepts and the end behavior. So let's go ahead and try some of these out here. So for number one, select all the true statements about g of x. So the first one is that its zeros are -5, -2, and 6. And yes, -5 would make it 0. Yes, -2, and yes, +6. All of those would make the entire equation equal to 0. The degree is 5. So that's not true because we have the multiplicities here, 2, 3, and then there's an invisible 1 here. So really the degree should be 6. So I would say that B is not true. Its graph will look like a quadratic function at the 0, -2. I would disagree because when I look at this part of the equation where the 0 is -2, it's going to look more like a cubic function, not a quadratic function, because it's to the power of 3. For D, the graph will pass through the x-axis at -2 and 6. I would say yes to that one because our multiplicities are odd. We see that it's going to be like a cubic function here and like a linear function at that x-axis. End behavior here. So let's see here. Since we said that it was a 6th degree and we see that it's a positive function, that means that both the left and the right side are both pointing up. And therefore, E is also true because our end behavior goes towards infinity to the left side and to the right. Which means that it's not going to be F here because we already decided what the end behavior was. Number 2, here is the graph of f of x. Let me zoom out here. Select all the equations that could represent this function. So there's multiple because different things can happen at the intercepts here. Let's talk about what our intercepts are. It's going to be -4, +1, and +3. So in this one here, let's see here, -4, that looks good, that looks good. Looks like -4 is good on all of them. The issue is that at this point right here, it looks like a linear function, which would mean that its multiplicity is 1, which means that it's definitely not going to be A because this one said squared, and definitely not going to be E because that one said squared as well. Now, the second feature I'm going to look at is what's happening at the intercept at +1. So it looks like it's a quadratic at that point where I zoom in. It's kind of bouncing off. So I'm looking for, it to be x minus 1 squared. And it looks like our remaining possibilities, B, C, and D, all have that. Next, I will look at the 0 at +3. That looks like a linear function at its point. It's going straight through. It's not a cubic or a quadratic. And so looking for x minus 3 to the power of 1, which is still true for all three of these. Now, when I look at it, the only difference is what's happening in the front here. So this one is a negative, which means that both the left and the right side would be pointing down. So I know it can't be B. And then the difference between C and D is really just this coefficient of 2, which is a stretch factor or scaling vertically. But we don't have any Y values on here. So technically, this could be either C or D could represent this function. For number 3, which of these graphs could represent h of x? So a couple things that we have here. I see that my degree is going to be 7, which means that the two end behaviors point in opposite directions. My leading coefficient here is negative, which means that my right side is going to point down and my left side is going to point up for my end behavior. So already I'm going to look at these and I see it's not going to be D and it's not going to be A because of the end behavior. Now we see that there are two specific x-intercepts, one of them at +1, which is a power of 4, and -1, which is a power of 3. So at -1, I should see kind of a cubic function, which is what it looks like here. Whereas this one, it looks more like it's bouncing off of that point. So that tells me that my answer here has to be B, because for the 0 at -1, it's going through, and for the 0 at +1, it's kind of bouncing off right there. All right, number 4, a fifth degree polynomial has a 0 at x equals 4 with a multiplicity of 3, and a 0 at x equals -1 with a multiplicity of 2. Which graph could represent this function? So first of all, I'm looking for a 0 at x equals 4, which means 1, 2, 3, 4. There's no 0 here, so it's not going to be A. Same thing with B, 1, 2, 3, 4. There's no 0 here, so not going to be B. This one, last two here, both have zeros. The first one here looks like it's going through. The second one looks like it's bouncing off. So even without looking at the other one, I know my answer has to be C here, because since it's a multiplicity of 3 at the x value of 4, it should be looking like a cubic function, which, yes, it looks like that for C, not so much for D. Number 5, here is the graph f of x. Select all of the equations that could represent this function. So key things that we're looking at here is that we have some sort of negative intercept, and we have a positive intercept that's a little bit smaller of a number. Also, it's got an even degree because they're pointing in the same direction, and then the leading coefficient has to be negative because my right side is pointing down. So with all those things in mind, the first thing that I at a quick glance can see is that it's not going to be D, because I see that it is a positive leading coefficient where it has to be negative. The second thing that I'm looking at, it looks like all of the pieces here that give me my two intercepts are squared, which is good because they look like they're both bouncing off at those intercepts. My negative integer has to be like a larger number than my positive one. And so in this case here, both of these would give me positive intercepts at 3 and 1. It doesn't give me a negative intercept, so I know it can't be A. For this one, we'd have an intercept at -6 and 2. That kind of checks out so far. That could be an answer, I think. This one is an intercept at -3 and +1. I would still agree that it could also be that. And then this one here, -6 and +2 again, with a different stretch factor than B. So I would say that all B, C, and E are all possibilities for this one here. For number 6, it asks us to write another equation for f of x. And again, it could be a lot of things. The main things that I need here are the fact that it's negative. I also need that I'm going to do the negative intercept to be larger. So let's say 8. And then that's going to be squared still because it's bouncing off. And then one of them has to have a positive intercept, like let's say 2. And that still has to be squared because it's bouncing off as well. Again, there's like infinite different things that you could do because there's no scale on this, right? You just need something that would give you a negative and a positive intercept, both of them having power of 2 and a negative in the front. All right, on to our spiral review. For problem 7 through 9, write each quadratic expression as a product of 2 factors. It's a long sentence just to say factor it. So I'm going to go ahead and use my diamond and box to help me with these. First term, first box, last term, last box. Middle term has to multiply to 6x squared, which would just be 6x and x. Then I actually factor these out to see that I am going to get, I'm low on space here, but I'll put all my answers here in blue. So I got x plus 1 times x plus 6 for this one. For number 8, same idea. First term, first box. Last term, last box. Middle term of 3x needs to multiply. So the two pieces need to multiply to negative 10x squared, which would be 5x and negative 2x. Then I factor using my box here. And my answer here in blue is going to be x plus 5 times x minus 2. And for number 9, first term, first box, last term, last box. Middle term of negative 11 has to multiply to 28x squared, which I would say is negative 7x and negative 4x. And then I factor to get my answer here of x minus 4 times x minus 7. So that's how we factor our trinomials there. For problems 10 through 12, determine how many real and non-real zeros each quadratic function has. In this, I'm going to use something that I know about with the quadratic equation to help me find out how many zeros each quadratic would have. Because my quadratic equation, negative e plus or minus the square root, b squared minus 4ac all over 2a. What determines whether it is real zeros or non-real zeros is what's in the square root here. Because if that inside of the square root becomes negative, then I'm going to get two imaginary solutions. If that becomes 0, then I get one solution or one real solution. And then if it becomes positive, then I get two real solutions. So I'm going to go ahead and use that idea to figure out, is this going to be taking the square root of a negative or not? In this case, for number 10, my b value is 1. So 1 squared minus 4 times 1 times 6. That gives me 1 minus 24. I end up getting the square root of negative 23, which means that I'm going to have two non-real zeros. Number 11, same idea. I'm going to go ahead and see here that okay, you know what, actually I want to change up a little bit on this one. In this one here, if I were to just start solving here, what I would see is that I'd subtract 16 from both sides and then take the square root of that. And since I'm taking the square root of a negative, I know that I get two non-real zeros again. And the last one, I'll go ahead and go back to my b squared minus 4ac. So b squared is 16 minus 4 times 1 times 4. 16 minus 16. And the square root of 0 is just 0. And therefore, I'm going to get one real solution or one real zero. And that wraps up our lesson 7 practice. The next up video will be lesson 8, and I hope to see you there.